Alright, hello? Alright, so I know we did this in class, but my document camera wasn't actually collecting what do you call it, video during the time, so it's just an extended podcast of problems you can't see. So instead I did this video to go ahead and show you what it would look like. Alright, so let's go and do this. This was from your practice exam that I gave you, which hopefully you did pretty well with. The answers were obviously online, but it wasn't really an accuracy grade, so it's not like that. You should have done that. You shouldn't have, there'd be no reason really to check it like that. Anyways, let's go and do this. So, number one gave you this list of ASCII values with letters, and needed you to translate where is it? A hexadecimal number into decimal to figure out what number it was. Now we knew that was what it was asking because after this long paragraph up here about ASCII that you already know about, it then says that we have the hexadecimal number 56. Now that's really important to notice because that tells you what kind of number this one is, and that's since you see that there's no hexadecimal column here, what you then had to do was translate 56, the hexadecimal number, into some kind of decimal value. So translate from hexadecimal to decimal, which hopefully you still remember how to do, but if you don't, here it is. Hexadecimal is base 16, so that means you have the ones place and the 16s place. The 5 is in the 16s place. So we're going to multiply it by 16. That's going to give us 80 when I finish this. And then the 6 is in the ones place, so we just tack on that 6 right there. And that gives us an 86 in decimal, which is V, which is C. So it's just the big parts about this one, provided you can still remember how to convert them, is being able to distinguish what type of number this one is. A lot of hexadecimal numbers end up looking like decimal numbers, and a lot of octal numbers look exactly like decimal numbers as well. You have to really read it to make sure you know what kind of number you're in and what kind of number you're making it. Just read the question closely enough that you can see that. Alright, moving on. There was this one. This one is one that you know how to do, but you might not have realized it. So these are basically just if statements, which you've seen in Python. So the or and the and, which we have probably seen by this point, it basically works as one of the two inputs has to be true in order for or to also equal true, and both of the inputs have to be true in order for it to for an and in order for it to be true. So the way you might think about this is if this were an if statement, it would say if. I'm going to type the rest of this because this is a nightmare. Alright, so if false or A. And that's in a situation where A is, well, we're going to see what kind of value A is. But that's what the OR gate is. Logic gates are just simply or if statements. So this says if either of these are true, which obviously one of them is already false, so A would have to be true in order for this to output true. So it's like if in a program, one of these two has to evaluate to true in order for the if statement to actually happen, which in Python has the. Now, the question itself gives you this little model, so you can basically skip the sentence in the model and just go down here and ask yourself, alright, well, which of these is true? A has to be true, A must be false, A can be either, and I think I just cut off D here. D is no value of A can make this output to true. That was option D. Option D wasn't actually the correct one. but I figure I'll include that. Alright, so let's do this. I have to figure out what value of A could make this actually be true. So here's how I go about it. I'm going to try option A first. A is true. So if A is true, so it goes false or true. And if you have trouble remembering that what false and true are, you can fill that in with things that are true or false, like if 2 equals 3, which obviously it doesn't, or 2 equals 2, obviously it doesn't, not both of those things are true, but is one of these two true? Yes. So it's very much like having this, false or true. Now, if you have false or true, one of them is true, therefore it evaluates to true. So go into our second if statement. If true and true, are both of those inputs true? Yes, then we output true. So I know that A can be true, so it doesn't have to be false, but maybe it could be false. And there's definitely a value of A that works to make it true. So now we just have to see if false could also work. So going in there, false or false evaluates to false because neither of them are false. Neither of them are true. And that then goes with our true and false part. If false and true and false are both of them true, no, then it outputs false, which is not that. So it can't be false in order to be correct, it has to be true. Moving on. How much time have you spent? Okay, let's keep going. Alright, for this one I'm just going to show you part of it. So let's just go ahead and test this out. Actually, I think we could probably go through the full thing. Let's do this. Alright, so I start off we have this robot grid, and we have some pseudocode. So let's see, n equals 3. Remember that 3 is stored in n, so n equals 3. That's how you write it in Python. This is how you write it in pseudocode. So repeat 3 times, and then we go inside here, repeat n times. Alright, so right now we're on the first iteration of this big loop here. Remember, repeat is basically your for loop, or if it's easier to remember, it's just repeating. So we go and repeat n times. What is n? Oh, it's 3. Okay. So move forward 3 times. So I move forward once, move forward twice, and move forward a third time. And I'm using arrows because then I can keep facing it in one direction. Okay, I've done it 3 times. So now I rotate left, and I subtract 1 from n to make it 2. Alright, I'm done with this part, so I go back up. Okay, repeat a second time. Well, I go a second time anyway. Alright, repeat n times. N is 2, so repeat twice. So I'm facing this direction, so I'm going to move forward once and move forward twice. Okay, and then we rotate left. And then I subtract 1 from n, making that a 1. Okay, and now we're on a third repeat. So this is our last time doing this whole process here. Repeat n times, repeat once to move forward. Okay, so I'm in this square facing left, rotate left, subtract 1 from n, and I've repeated that 3 times now, and I'm all done. Alright, yeah, good. So hopefully you see how we did that. Alright, let's do this one. So this is one that you might have gotten wrong. The reason is some of you tried to fill in elif here, like in Python. There's no elif there. The important difference between if and else if or elif, because that's what it is in Python. So I feel all of you are used to that, though you still have else if. You remember that these are the same thing. All right, now the big difference between if and else if is for else if, it only happens if the previous if statement didn't happen. That has to not happen for this one to happen. But if it's just if, both of these if statements can happen. So I'm going to work through one of them and show you why that's not the right one. So for instance, B. I'm going to move this grid on up here so that way we can see it. So let's start off. Alright, repeat until goal is reached. Goal is reached is defined as the robot is in the gray square. Okay, and I'm trying to figure out which one of these do not correctly move the robot to the gray square, so let's try it. I have to try each of the options. That's my only option there, is to try each of the options. Alright, now, if I can move forward, I should move forward. That's what the first if statement says. If I can go right, I can't. Okay, can I move left? No. Alright, I'm done with that. Repeat, because I haven't gotten to the gray square yet. Move. If I can move forward, do so. I can. Can I move right? Yes, so I rotate right. So I'm just going to draw the arrow facing that way. Can I move left? No, so I don't rotate left. And notice that I'm asking for each of these, even if I did the previous if, I still check the other if statements, because it's not an else, or an else if. Okay, start again. If I can move forward, I do. Can I move to the right? No. Can I move to the left? No. Go back to the top. Can I move forward? Yes. So do so. Can I move right? Yes. So rotate right. Can I move left? No. So back to the top. Can I move forward? Yes. So I do. Can I move right? No. Can I move left? No. So can I move forward? Yes. And that process is just something you would continue until you finally reach the gray square and saw that B isn't your option. So that's how you would solve that kind of problem. I think you see basically how we do that, and you just go until finally you reach that thing here and said, oh, B does correctly execute. So that wouldn't be the right answer because it does work for that. Moving on. Oh, this is our last one here. Alright, so this last one that you guys asked for in class was there were 32 students standing in a classroom. 2 different algorithms are given for finding the average height of the students. So this might be something you're asked about. Usually some kind of shuffle method is really popular. I don't know if College Board is just full of card players. If I'm any indication, then yeah, they are. So that's how I hear this. So here's our first. We have to compare 2 algorithms and figure out something true about them. And the statements that we're looking at are, we don't care. Let's look at the algorithms first. Step 1, all students stand. Step 2, a randomly selected student writes his or her height on a card and is seated. Step 3, a randomly selected standing student adds his or her height value on the card, to the value on the card. So there's one card that has one person's height, and now it has another. Records a new value on the card and is seated. The previous value on the card is erased. So right there we just had some data gain erased, but does it matter? Well, we're trying to get the average height, which the arithmetic mean average is based on getting all of them added together and dividing it by the number of values. So we don't really need to keep track of all the values, just their sum. So the fact that it's erased is fine, because we have the total sum so far. Step 4 is to repeat step 3 until no students remain standing. Well, that means you just keep randomly adding a person until you've gotten all 32. Then that sum is divided by 32. The result is given to the teacher. Okay, that algorithm works fine. That would get the average height of the classroom. Remember though, median's better. Alright, next up. Algorithm B, all students stand. Each student is given a card. Each student writes his or her height on the card. Standing students form random pairs at the same time. Okay, so right now we have 32 cards of heights. So right now everyone's height is written down. So let's see if we can keep that data and put it together. So each pair adds the numbers written on their cards and writes the result on one student's card. The other student is seated. So we go from having 32 separate values to having 16 combined values. And the other 16 are sitting down. So their totals have been put into the total and are not counted anymore. So that looks pretty good. Repeat step 3 until only one student remains standing. So that means we've gone all the way down from 8 to 8 to 4 to 2 down to just our last person. And then that last card, that sum on that card is divided by 32 and results given. So you see that one is, though it's a little weirder, does work as well. So let's look at our things. Algorithm A always gets correct, but B does not. Well, that's not right. B gets the right answer too. So that means the next one that says algorithm A does not get the right answer is also wrong. Both of them, however, do get the correct average, so let's think about that. D is neither of them? No, okay. Yeah, they both work just fine. They both are good algorithms. They work anyway. Okay, and that is just some of the practice problems we had on that, and hopefully that going back over it helped you, as did doing the practice exam yourself. Alright, I'll see you guys soon.